Hello, this is Team 8, and today we're providing some examples of Python techniques to deal with image processing. So our team is composed by Joe, Robert, Nick, and Edmund.
So we explored the processes of smoothing, edge enhancement, and edge detection. Smoothing is depicted on the image on the left. The leftmost image within this is the original, and the right one is the smoothed image. Smoothing is used to reduce noise or pixelation in an image. An application of this is to create stable videos at different refresh rates. Edge enhancement is the middle image. The top of it is not enhanced, and the bottom is enhanced. Edge enhancement is used to enhance the contrast between edges in an image. It is often used in TVs and printers to create higher quality natural looking images. Edge detection is the rightmost image. The left is the original and the right is the edge detected image. Edge detection allows the identification of objects and many of their attributes. These include the number of objects, their sizes, shapes, and locations, all of which can be stored and used as data. An up-and-coming use of this is in autonomous cars, in which a virtual world can be created that they interact with.
Edge restoration is the use that applied all the techniques Nicholas just explained. People generally use edge detection skill to find the abrupt change of brightness, and then use a smooth matrix to fill in the desired color or pixels, just to create so the enhanced image. That looks better. And just no, it's like Edmund. Edmund's going to explore what these techniques looks like.
So when we have an original image, in order to make it easier to process the image, we convert it to grayscale. And since we are dealing with a still image here, we're going to use the international recommendation called BT.709, which uses the weights for the red, green, and blue values of the image. So in the code, we're going to run the code here. And once it's done running, you can see the results. So in the main, it first shows the original image and then shows the grayscale version of that. And in the convert grayscale.py file, you can see that what the colors do are it takes the original matrix, which is an RGB value, and it takes 0.2126 of the red values, 0.7152 of the green values, and 0.0722 of the blue values, sums them up and adds them to sums them up to create the grayscale values of the matrix, so that once you sum them up, you get a matrix that finds the grayscale values of the original matrix. So as you can see here, this is the grayscale image of the original. Furthermore, images have a lot of noise from the original. So what we want to do is that we want to take a 3x3 window and average all the 3x3 windows in the original image. So that what that will do, that will smooth out any noise or it will make the image more blurry, but it also reduces the noise that comes out in the end of the process when you're done processing the image. So in the code, that happens in noise smoothing.py. So here, we take an RGB or the RGBA value, and you create a 3x3 by 3 matrix or a 3x3 by 4 matrix, which are all composed of ones, and then you divide it by the sum of its elements so that it doesn't change the brightness of the grayscale image. And what that will do is that in these for loops, it will multiply each of the 3x3 windows of the grayscale image by the averaging filter, and then it'll create a new image that is blurred from the grayscale image. So as you can see here, we have a new image that is like the grayscale image, but just slightly blurred. Joe?
All right, so the way edge enhancement works is it calculates the gradient to detect sudden intense changes in the color of an image. And we did this with a Sobel operator. It finds the partial derivatives in both directions. So we used the vertical and horizontal component and then took the magnitude of that to calculate the gradient. And after this is done, the center point of each selection of pixels is used as the pixel in the new image. So in the code, you can see that we have two different options for the red, green, blue alpha, and then a regular red, green, blue. It detects whether or not the pixel or the image is using red, green, blue alpha or the original. And based on that, it'll choose the correct operator. It then goes to the computation function, passing the necessary size, the new image, and the image data. So the first part of it, it will take the local pixels from the original image. It will create a 3x3 matrix. It will then transform those pixels using the horizontal Sobel operator to detect the horizontal edges in the image. It will then do the same, but in the Y direction using the Sobel Y. After that, it will take both components in the horizontal and vertical directions and take the magnitude of that to calculate the gradient or the sudden intense changes in the pixels of that part of the image. After that, it will take this new value and place it in the new image of zeros that we created earlier on. So finally, it finishes with thresholding. So with the new edge enhanced image, you'll have a variety of pixel values ranging from 0 to 1, but because of this is not just two different colors, it's a range. So the point of this is to take all the values in the image and set them to one or two colors, or one of just two colors, either 0 or 1, to be able to easily distinguish the lines in it. So the way that this code works is that it will intake the image as before. It'll take in the edge enhanced image. It will pass it through another loop. And if you'll define a certain threshold value. In this case, we use 0.3. So any pixels in our original image, or the edge enhanced image in this case, that are greater than 0.3 will be set to 1. And then otherwise, all values will be set to 0. And because of this, you'll get a new image with easily distinguishable lines. And this is the final step in edge detection.
Finally, we will show one more demonstration of the edge detection using a different picture. As you can see, it takes a while for the code to run, as it is very computationally intensive. So as you can see, we have the original, the grayscale, which is done using the convert script grayscale.py, and then it's blurred, edge enhanced, and then all the pixels that are above a certain threshold, which is 0.3, are set to full brightness.